Next, we move on to model building with like the selected features. So from sklearn models selection, import train test split. From sklearn metrics, import accuracy score, classification report, confusion matrix. And from sklearn linear model, import logistic regression, and sklearn and assemble, import random forest classifier. Then we move on to xtrain, xtest, and ytrain. Ytest is equal to train test split with these parameters. Basically, this splits the data into training and testing sets. Then we move on to model is equal to logistic regression, max iteration is equal to 1000, model.fit xtrain, ytrain. Basically, this trains the simple logistic regression model. Then we do ypredict is equal to model.predict xtest, then accuracy is equal to accuracy score, ytest brackets ypredict. Then we print out the model accuracy accuracy.point4f. Basically, this block of code evaluates the logistic regression model. Then we do print a classification report, brackets ytest ypredict. Basically makes the classification report for the simple logistics regression models. Then we move on to RF models equal to random forest classifier with these parameters: RF model.fit xtrain and ytrain. Basically, this trains the random forest model for comparison. Then we move on to RF predict is equal to RF model.predict xtest. RF accuracy is equal to accuracy score, ytest, yrf predict. Print random forest accuracy, RF accuracy equal to 0.4f. Basically, this evaluates the random forest model. Then we do print random forest classification report, print classification report, brackets ytest, yrf predict. Basically, this creates the classification report for the random forest model. Then we move on to comparing the models of the logistic regression score accuracy and the random forest accuracy. So the first model is the logistic regression model with the accuracy score of like 95%. And this is the classification report for the precision, recall, and F1 score and support for non-diabetic cases, which is class 0, and then diabetic cases, which is class 1. Then we have the random forest accuracy score of like 96%, 0.9. So it's slightly better than the logistic regression model. Then we have the classification report for the precision, recall, F1 score, and support non-diabetic cases for class 0 and diabetic cases for class 1. Then we see the comparison model between comparisons to logistic regression accuracy, as said before, 95% compared to random forest accuracy, which has at 96%. So it's slightly better by 1%. So yeah. Then we move on to fig axis is equal to plt.subplots, 2, 1, fig size is equal to 8 to 12. And then we move on to ssn.heatmap with these parameters all the way down to axis brackets dot set white ticket labels, parentheses, brackets, no diabetes, 0, diabetes is equal to 1. Basically creates the confusion matrix for the logistic regression, and which is like the same thing down here for the random forest classification. So we have the logistic regression confusion matrix over here. So we have the true negatives, which is like 18,000. Then we have like false positives with like 165. Then we have like false negatives with like 658. Then we have true positives, which is like 1,050. And then we move on to the random forest confusion matrix with like true negatives of like 18,200, which is better than like the logistic regression model. And then we have the false positives with 82, which is better than the logistic regression model. Then with like false negatives of 521, which is still better than the logistic regression model. And then we have with true positive of like 1,187, which is better than like the logistic regression. So yeah, so this was the entire project. Thank you for listening and watching.